Yeah, you can't. I guess it cuts off early. Sorry about that.
Okay, I mean, under normal dropping.
All right, good morning. How's everybody this morning? Good, Jeffrey, you good? Yeah. All right, so this week's code of conduct is strive to maintain a positive and professional image of ECI of our employees, our clients, our vendors, subcontractors, and the public. Yeah, they try to build ourselves up, not tear us up. So this week, really challenging week. A lot of changing conditions. We got those cold temperatures rolled in, and a lot of ice and snow. So we did well, though. We had a couple close encounters with slip, trips, and falls with icy conditions. So again, look at that hierarchy of controls. It's one thing that we can eliminate in our job sites, and that's ice. We got the ice melt. Let's use it. Let's make sure you got some on your job site, in your truck, trailers, wherever you see ice. Don't leave that landmine for the next guy. Let's just take care of it. Let's just really try to get that ice melt done as much as we can. So we're up to 76 days without recordable injury, and again, our record is 145. So, we're trending in the right direction. And this week, highlighting is just some winter driving tips. I have a little video here of a professional driver, just some of the tricks and trades of if you start losing control or things that you can do in your vehicle to hopefully avoid an accident. Again, with winter driving, the most important thing is everything is what you can control, your environment, what's around you. So again, that following distance and how you're positioning your vehicle with other vehicles in snow is extremely important. So if you're tailgating, things like that, you're not going to have enough reaction time plus the speed that you're going at to stop. As we see a lot of our incidents sometimes is in those fender bender types of situations, and then of course always those backing situations. So cleaning those mirrors out, doing that walk around, making sure you got good visibility, and creating a good distance between your vehicle and all the vehicles around you. I know you're not 100% in control of that because a lot of other vehicles might be right on your butt, but you can always pull over, let them go by, and those types of situations. So I'll fire up the video here. Get to work.
I'm Mark Stolberg from Master Drive. We're here to talk about winter driving. Here's a tip for visibility. Turn on your defroster, which should disable the recirculation button. Some cars you're going to have to turn off the recirculation button and get vent to the outside air. That will help clear the fog that's inside the windows much more quickly. Technique needs to be smooth in steering and braking and accelerating. I can snap the wheel and the car is still going straight because I moved the wheel so fast tires couldn't respond. Or I can move it more progressively and the car actually turns. Smooth acceleration, gradual progressive application of the throttle, and we're able to make progress really well. As opposed to putting the gas on too abruptly, and we're just going to spin our tires. You can use your transmission to your advantage in slick conditions. If you're trying to accelerate, the lower gears, first gear, gives you a lot of torque and likes to spin those tires. In a car, you can select that gear and you can go up to second gear. In a stick shift, you just choose second gear. In automatic, oftentimes there's a setting, if you check in your owner's manual, where you can start out in second gear. By starting out in second gear, the engine is not in its power band, it doesn't have its own torque, and you're less likely to spin the tire. Traction is provided by the road, not by the car. So the tires are really able to take advantage of the available traction based on their specific design. In the winter, the compound needs to be softer again because the temperature is lower and needs to stay pliable. And that tread design is specifically designed for snow or grip on ice, and it has a lot of edges to it. Sometimes you want to drive in the tracks that are left in the snow on the road. If those tracks are dry, drive in them. But if they're icy, then drive outside of the tracks on the snowpack right next to it, and you're going to get a lot more grip. The technique for recovering from a skid is to look where you want to go and to steer in that direction, using smooth, progressive inputs to the steering wheel. Also, do not put on the brakes and do not put on the gas. That just adds more force to the skid. You want to reduce those forces, get the tires lined up, and allow momentum and the rolling of the tires to get you back on your path of travel. Spin control picks up where skid recovery left off. So if the car is going to go too far, it's going to go around to where it's going to go to backwards. The key is to get all four wheels lined up by the time it gets backwards. That way, when they're in alignment with the momentum, they'll roll and the car will stop spinning. Important is that if you did this, you have no idea whether that's straight or not. Versus if you use good steering technique and you had done two of these in your skid recovery, then you do two of those and you are back to straight, back to neutral steering, which is the key. If you get stuck in the snow, spinning your tires isn't going to get you out. It might melt the snow and make it slicker, might dig a bigger hole. One of the things that you have at your disposal is your floor mat. Simply clear out the snow, put the floor mat under the tire. Then when you back up onto the floor mat, it gives you grip, the tire doesn't spin, and you'll get enough momentum to get out of the snow.
So, any questions? Some good tips there. Some things to think about. Especially I thought biggest thing was trying to get yourself back to parallel with the road, because a lot of times when you start spinning out like that, you just keep spinning and spinning and hitting guardrails, other vehicles, stuff like that. I thought that was a good little technique there. No other questions? I'll pass over to Ken.
Okay. Thanks, Matt. I'd just like to remind you, Matt, that it's not even winter yet.
Oh, yeah, true. It feels like
it's not
it.
winter. Don't worry, it's not winter. Don't let things psych you out here, huh?
Yeah.
Next week, end of next week, right? I think one of the keys to winter is be patient in driving. As much as anything, be patient.
So, corporate announcements. We've got the holiday barbecue party from 12 noon on Friday. That's next Friday, a week from today, the 22nd. That's the last work business day before Christmas. Wow. And then for the holiday schedule here, we have the 22nd. We're going to close at noon. Christmas Day, of course, is a holiday. Office closed. And New Year's Day, Monday the 1st, offices are closed as well.
So we got to also make sure we get all the time cards in and everything too. We'll be really strongly reminding everybody next week in the announcements.
So technical tips. We're still talking about measuring devices and the dial indicator, which is right here. It's a measuring device for small movements. We use them on anchor and pile load tests to measure deflections. The devices we have are used with an accuracy of 1/1000th of an inch for the analog one here and 1/10,000th for the digital system. And the digital device is significantly more user friendly too, and therefore it's better for when you need reliable measurements, which is usually why you're using the device. There's the digital one. I've got the actual devices here. So our dial indicators are particularly expensive due to the need for 2-inch travel. See, that 2 inches adds a lot of cost because they're not very they're not as common in the market. There's a lot of indicators, and especially the electronic ones that are pretty cheap, but the 2-inch travel is what we need, and those are very expensive. Those are necessary for load tests because of the amount of travel we might have on a anchor, or especially anchors. So we use also magnetic bases. Actually, it's got an arm there, and we attach it to a metal surface, and it's usually important to have
the measuring device is independent of the whole test frame. So I've got this is the analog one. You get it over here in the light. And so you put it on a device, you hold it separately. There's actually a little bit of a grommet or a D-ring on the back. And so when something moves, this should stay stationary. When something moves, it measures that deflection. And so what you might do, especially whether you're going in tension and say your anchor's coming out of the ground, or if it's in compression, it's going down, you got to kind of set it at the right stroke level. These are really hard to read, and it's fairly simple as long as the movements are only within that dial. But once they go round and round and round, especially multiple times, it's tricky. And even the little secondary dial there can be moving in different directions, and you don't know whether you're on, the high side of 5 or the low side of 5. So are you in the 4 range or the 5 range? So pretty challenging there. That's why we like to use the newer digital one. That mat didn't have to be flipped around. Oops. And the digital one has seen a little hard work. But that's simply, and one of the things you'd have to do there is maybe set a 0 and stuff like that, or get an initial reading. But this one, you just hit the on button, and then you can just do a clear. And it's the same thing it was working last night. Probably it's a battery operated thing. But again, it's got the 2 inches of travel, which makes this a very expensive device. But it's nice you can hit the clear button, the reset to 0, which is a lot simpler. And then the readings are just read it off. Okay, so moving on, we have for projects this week, we're talking about the V-Trans railroad culvert replacement projects. There's 3 different projects. We're under 2 different contracts. One, we pretty much just abbreviate culvert A and D in Ferrisburg. That was one contract. And C in another contract was in Ferrisburg. And B was last year that we did in New Haven. So these 2 projects, the work involved 50-foot long culverts in the first contract, a pair of them, one at different sites, and then a single 100-foot on the C contract in New Haven on Dog Team Road, and all of them are under the Vermont Railway, involved concrete head wall structures, and it replaced all of them replaced existing stone box culverts, which were heavily damaged from storms back in 2011. New culvert pipes were installed in the 72-inch diameter steel casing pipes, installed by trenchless methods like ramming, and some had guided bores and that sort of thing, so we did directional bore to get a guide tube in line. And the new head wall structures consisted of a hybrid precast and cast in place components, and were mechanically tied to the steel casings to help resist the high lateral earth loads from the railroad. So the casings acted as a big tension anchor in a sense from head wall to head wall. Excavation support systems were installed at the inlet and outlet ends. In order to build these head wall structures, we needed a lot of room behind them and against the tracks there. And we also needed we built a combined on all projects 1.25 miles of temporary access roads with gravels, fabric, and some temporary culverts, that sort of thing. Actually, I don't know if we had temporary culverts, but there were areas where water had to flow over. Trenchless pipe techniques were combined with strategic planning and integrated structural design of the head wall structures, and the culvert pipes allowed for the use of smaller cranes and smaller excavation footprints and did not require railroad shutdowns too. So obviously the smaller your footprint, the less impact on everything. There was wetlands and all kinds of things to consider there. The head wall structures were designed by a collaborative effort between us, Simpson, Gumpertz, and Hager. They're a structural engineer out of Boston, Camp Precast, and Engineering Ventures. I think that Engineering Ventures basically did the shop drawing design for Camp Precast. And then the greatest technical challenge was coming up with constructible and cost-effective design for these head walls. Other designs would have required larger cranes and pile driving equipment, deeper excavations, larger project
footprints and other logistical challenges. And in the end, the head wall structures consisted of precast footings and wing walls with cast-in-place head walls, which mechanically tied into the steel casing pipes. I don't think all of them were.
I don't know what that is.
So, Joey, not all the,
Yeah, the next sentence.
yeah, okay, all right. I played around with it here and it probably got changed, I guess. So in unanticipated rock conditions required ECI to change the precast to a cast-in-place structure for the 100-foot long culvert because the rock was higher. We actually moved the pipe up. We had the precast system would have meant rock excavation, which didn't make any sense. And we had different heights to adapt to the existing top of rock elevation. So that was done as a cast-in-place. And the work was just completed recently. There's back at the beginning of the year at one of the culverts, I don't know which. And then handling some of the casing. That's probably just a 24-inch. We did.
That's 72.
That's a 72? Okay, but we started on a lot of these, all of them, I think, right?
Just 2 of them.
Just the 2 of them, just the first 2. Stepped up the size from a guide pipe, drilled by HTD, to the 24 to the 72. And that would appear to be the 24-inch casing there. See that? We get some pretty tall workers down there. And then this is the 72-inch casing installed, and you see there's a I forget what the material is.
Polymer coating.
It's a polymer coated, so they call that a PCCP, I think, right? A polymer coated corrugated pipe, and that was provided by Contact. And that was grouted in, that was installed, and then the head wall and wing walls, the wing walls first and the footing first, obviously, the footing, wing walls, and then the head wall was installed between those wing walls, and then it also engaged with the casing pipe to provide resistance from the earth pressures from the railroad.
Kind of cool stuff.
This is the back side. So we had to have sufficient room to build the footings and get the walls in. That's the need for the sheeting. And there's a completed one of the culverts with water flowing through it, it looks like. Good job. Very technical job. Very interesting one. So this is one of the photos. Sorry?
Did the sheeting stay in?
The sheeting came out, for the most part. I don't know if we left any in, but it pretty much came back. So this is a photo from the Jens Hydro Dam. And this is right in the town of Virginia at the Otter Creek. We did a lot of demo work and other work for Pizzagalli as a subcontractor to them, and Green Mountain Power is the owner of the dam. This was a big intake to the penstocks, and there was a lot of demolition that went on around that. So those track trucks were pretty handy in bringing that debris out.
So that's what we got. Have a good, safe day out there.
Jeff Barber. Like your ship.